Hey everybody, this is Mr. Storm. In this video, we're going to continue building our Arkanoid game. We might actually finish it in this video, to be honest with you. Hopefully, that'd be nice if we got to finish this up. Let's do a review of what we've done so far. So far, we have a game where the ball can collide off of the edges, and it can collide off of the paddle, and the paddle can move back and forth. Now what we need to do is we need to create a system where when the ball enters this bottom area, we reset the game, okay? So this is actually going to be pretty easy, probably easier than you're thinking. It's going to require one line of code, really, in our ball script. Well, a new function and a line of code, but we need to set this up first. First, we need an area. So a new area 2D. And this area, let's call it reset. And let's give it a collision shape 2D. So this shouldn't be too much of a struggle because this isn't really new. We've used areas in the last project. For this project, we're going to use the area to reset the game. So we're going to put it down here. Want to make sure we're not touching the colliders that are already here because we don't want this to trigger unnecessarily. But we're going to catch it. We're going to have it down here so that the ball has no choice but to hit this area whenever it comes below the screen. Okay. Alrighty. And then what we're going to do is we're going to set up a body entered signal so that triggers. So whenever the ball hits the reset body or the reset area, it does something. And the thing that it's going to do is literally just reset the level that we're in. So the way we do that is we say get tree. Now, get tree basically says get this hierarchy structure. So it's saying get this entire structure itself. So get the game scene, get the whole thing, get everything that's in this, get it all at one time. Okay, now get tree, and then we're going to run a function on get tree called reload current scene. It's that easy. Basically what this is saying is whenever something collides with that area, we're going to just reload the scene that we're in. It's that simple. And you can use that code to reload any scene in any of your game projects. There you go. And it just starts all over again. The ball goes where it's supposed to. The paddle goes where it's supposed to. So now we can continuously play our game even if we lose. Now, some improvements that you might want to make if you were expanding on this idea. Inside this reset body entered, you could have a variable called lives that reduces by 1 every time we reset. And once lives gets to 0, then the game is over. There's some things we can do here to make it more interesting, add some more challenge, that kind of thing. But for right now, we'll just have it reset the game indefinitely. Okay. Alrighty, now let's make some bricks. This game is pretty boring because there's nothing for our ball to interact with other than the edges. So let's make a brick. And this brick is going to be a kind of a complicated object. Yeah. All right, let's get into it. So our brick is going to stay in one place. The bricks aren't going to move at all. Matter of fact, they're not even going to have physics applied to them. So we don't want gravity to be exerted on these things. We don't want them to be pushed around by the ball. When the ball bumps into them, we want it to just delete, okay? We don't want the ball to like push it off a little bit and then it deletes. So we're going to use something called a static body. We've used these before, but we've never used them in this kind of context. We're going to create a static body. We'll call it brick. And let's give it the normal nodes we use. So sprite 2D. And let's give it a collision shape. And the sprite is going to be our icon. Boom. Let's make this a little bit smaller. So let's go 0.5. Yeah, maybe. Does that kind of look like a brick? Let's do, that's a little better. All right, and let's change the modulate property so that it is a black brick, and then we will set up our collider. Okay, perfect. Kaboom, kabloom, kablam, kabloozy, kabloom. There we go. Okay, so our brick now has a collider and it has everything we need. The problem is, if we take a look at the nodes that we have available to us, the signals we have available to us for a static body 2D, none of them are the nodes we want. I don't see any on body entered. So this isn't really going to help. This is going to be a little bit more difficult. We have to think about this a little bit. So we don't have the events that we want. And part of that is because this static body node isn't really intended to be used in this way. Generally, when we want something to interact with the rest of the game, it should be an area or a character body or even a rigid body. The problem is if we use one of those kinds of nodes, there's problems with each one. If we used an area for this, then the area would ignore all collisions, and you'd be able to pass right through the brick, and the brick would delete, but the ball wouldn't bounce off of the brick. So that's not really the solution. A character body or a rigid body would automatically have physics applied to it, and so it would kind of not behave the way we want it to. Plus, the signals aren't really the nice. So here's the deal. We're not actually contained, or we're not constrained, rather, that's the word I'm looking for, by just one node type. So we can actually create a child of this static body. We can create an area as a child of this static body. And that area can have its own collider that the character can pass through. And what we can say is we can have that collider be a little bit bigger than the physical collider on the static body. And we can say whenever the ball passes into that first collider, then we're going to delete this object. But we're not going to do it right away. We're going to wait like 0.1 seconds so that our ball can bounce off of this object, then it gets deleted. Okay? So I know it sounds like it's a complicated fix, but it's actually a pretty elegant solution to a problem that we have with just the way that nodes are created. So let me walk you through this solution to this problem. First, we need an area 2D. All right, and then this area needs a collider, so a collision shape 2D. Let's give it a square, and let's make this rectangle just slightly bigger than the rest of the object. Okay, so it's just a little bit bigger than the rest of the object. All right, and then what we want to do is we want to use this signal on the area, the body entered signal. So there's the signal we need. We're going to use this signal. Oh, first we need to attach a script. Sorry, that's why it wasn't working. Let's attach a script to the brick itself. We'll call it brick, sure enough. And let's delete everything here because we're not going to need any of that. Now we can go and attach this signal to the brick script. So now it says on area 2D body entered. So whenever we enter in that area, or we pass into that area's collider, we want to do something. Now the first thing we want to do is check to see if the object that we're colliding with is the ball. All right. The reason why we want to do that is because notice that these two colliders are colliding with each other on automatically. If we don't check to see if it's the ball, if we say any collider at all, let's delete the object, then as soon as the game opens, our bricks will delete themselves because the colliders are already overlapping by default. So we need to check to see if it's the ball. And there's actually a pretty nice way to do this. What we can do is we can put this ball into something called a group. Notice that over here we have signals. We also have groups. So if we select our ball object and come over here to groups and click plus, let's create a new group called, let's call it player, just to make it different from the object name. And we make sure that our ball is a part of the player group. Now we have this little icon next to it telling us that it's in a group. Then in our script, in our brick script here, we can say if body, now body is the thing we've collided with, so that's what it's called. So this function is going to return something to us, and it's returning something called a body. And so we're saying whatever we collided with, if body.is underscore in underscore group. So we're looking to see if the body that we collided with is inside of a specific group, and for us, the group is player. So if it is in that player group, then we are going to use something called a queue free. Queue free. Okay, queue free is a command that just deletes the object. All right, let's save this. And let's save our brick, because we haven't done that yet. Let's save that. Let's go to our game and let's add in a brick. Let's instantiate a brick real quick. And we'll put it somewhere in the level where we're going to be able to bump into it. Let's put it like, I don't know, like right there. And let's play the game and see what happens. Look at that. We bounced off. And we're getting some weird glitchies going on here, but I'm okay with that kind of. It looks kind of nice. Now, this is working the way I want it to, but it's not working in the way that I expect. I expected it to not, I guess because I made the colliders close enough together to where it's triggering this collision and that collision in roughly the same frame. So we're able to bounce off and delete the object without too much of a hassle. But if for some reason, when you're doing this, if your ball is floating right through the brick, let me make my collider on this area just a bit bigger so that we can see what happens here. And let's play the game. So if you're doing that, if the ball is floating through the brick and not actually colliding with it, then we can fix that by doing, or we can fix that in the code. So let's go ahead and do that. So queue free is going to happen as soon as it gets called, just like everything else in the game. But if we don't want it to happen right away, if we want it to wait for a minute, we can use a command called await, right? It's a pretty simple command. Await, basically saying we want to do something, but we're going to wait until a thing happens. So for us, it's going to be get underscore tree, because we're going to get access to the tree here, and we're going to dot create timer. So we're going to add a timer to our scene, and the timer is going to be a 0.1 second timer, and we're going to wait for timeout. So this is doing a couple things for us all in one step. We are going to create a new timer node in this scene that lasts for 0.1 second. And we're going to basically trigger, we're going to wait until we hit the timeout. So we're going to, this line of code really essentially is what it's doing, is it's saying wait for 0.1 second before you move on to the next line of code. That's all it's doing. And then we can do queue free, which will, so this is going to wait 1 second and then it'll delete. I'm going to actually change it, or point 1 second. I'm going to change it to 1 second just so you can see what we're doing here. You can see what the effect is. And I'm going to move this brick a little bit more in the path. Okay, let's see what's happening. So the ball interacts. So you notice that it interacted with the brick and it waited for a second before it deleted itself. Okay? Perfect. So we can use that await to basically fine-tune when we want our bricks to get deleted. So this should happen almost instantaneously, and it looks pretty natural, right? So even though our collider is much bigger and our ball is hitting, for demonstration purposes, our ball is hitting this collider in a different frame than it's hitting this collider, even though that's happening, we're still able to get the brick to delete itself after the ball bounces off of it. Whereas if we didn't have that await, what would happen is the ball hits this collider, it deletes the object, then there's nothing for the ball to collide with, right? I hope that makes sense. So we can fix some problems with the script if we just think about what we want to have happen and figure out a way to make that happen. So this timer right here is a really handy tool that we can use to cause things to happen in the correct order in our game. All right, last thing we need to do is we just need to create a bunch of, and I'm actually going to go back to my brick and I'm going to reduce this collider size real quick just because I don't want it to be that big, because we're going to put these bricks next to each other and I don't want them deleting each other as soon as the game opens. All right, and let's save all scenes. Why is it like that? Okay, there we go. So I'm going to add a bunch of bricks to this game, probably 20 bricks or so, right? So I don't want to add them all in this menu without having the ability to hide them. So I'm going to create a new node, and it's just going to be a node 2D, and I will call it bricks. And I'm going to add this brick as a child. Perfect. And then I'm also going to turn on the grid. Up here on this view here, we can see that we have a use grid snap button. I'm going to turn that on, and it's going to give us this grid. It's kind of hard to see, but it's going to give us this grid, and whenever we drag our objects around, notice that they're kind of snapping into place. They're snapping into place on the grid. That's what I want. Okay, so now I can Control D to duplicate my object. And I'm trying to make sure they're spaced evenly away from each other. I'm going to put 5 on this row. And let's select all of these here and let's move them over just a little bit so that they're more evenly spaced. Okay, perfect. Now I can duplicate all 5 of these at once and drop them down. Do that again. Drop them down. Do that again. Drop them down. So now I have 20 bricks in my game. All right, let's save it and let's play it. Ooh, that was beautiful. Nice. Did you see that? Just went right up the edge there and got rid of all of them. Kabink. Look at this. This is fun. Now, there's some problems with this game. First of all, we could play it forever until we win. And that's not that's kind of an issue. The other problem we're starting to see now. Look at this. I am trapped in a loop. Notice that the ball doesn't actually change its direction, change the direction of his bounce. In Arkanoid or Brick Out or any of these style of games, the program or the paddle is programmed to reflect the ball in a different angle depending on where on the paddle the ball hits. Now, we could do that, but it's a bit complicated to explain, so we're not going to. That would be something that you could try to figure out on your own. I'm not going to walk you through that process because, again, the math is a bit complicated. For now, I'm pretty happy with this final product, even though our game's a bit broken. But you know, I enjoy. I think we have some good stuff here. We've learned a couple new concepts. We've reviewed some concepts that are kind of fundamental to our game development journey. What we could do is we could change the speed of our, or change the direction or the angle of our ball here, so that it goes at a different angle, which will give us a different outcome. Nice. Anyway, we could play around with it. Again, I'm not gonna try to fix that problem. It's a lot of complicated math. What I am gonna do is I'm gonna leave it here. I'm gonna let, oh, that was weird. I'm gonna let you guys figure out if you want to make some changes to it, see what you want to do, see if you want to, I don't know, try to figure out how to make the ball reflect in different ways depending on where it hits the paddle, try to add other features to the game. But at this point, the game is pretty much what I want it to be. All right, so cool. That's it. Next time we'll get into a new project. All right, cool. Thanks for paying attention. I'll see you next time.